Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good morning. So, thank you for joining the class. Today we will continue our dynamics class. We are currently in chapter 3 lah, which is the last chapter of dynamics. So we have finished with chapter 2, where we talk about the force and acceleration, or basically the Newton's second law of motion, F equals to ma. And the last chapter is divided into two components. One is what we are going to discuss today, which is the work and energy method. And there will be another topic under chapter 3, which is impulse and momentum, that will be covered later in week 13, perhaps. Okay, so today we will focus on the work and energy method. So there are two keywords here, which is one is work and the other one is energy. So first, we are going to focus on the energy first. Okay. So when an object is in motion, what kind of energy the object has? Anyone?
Kinetic.
Kinetic energy, yes. So when an object is in motion, okay, is in motion, so it will have kinetic energy. Okay, kinetic energy. So this is the one or energy that we will discuss today. How do you calculate kinetic energy? Because this is important. Later, we will learn about the principle of work and energy, and it involves kinetic energy. So, who can tell me what is the formula to calculate kinetic energy? You have learned this in physics before. Kinetic energy. Any idea?
1/2 mv square.
1/2 mv square. Good. Okay, so kinetic energy in you can maybe previously you call it as Ke, which is equal to 1/2 mv square. In dynamics, we will call kinetic energy as we will use the symbol T. Okay, so for kinetic energy, it will be T, which is equal to 1/2 mv square. Okay, but this is only for one type of motion only, which is translation. Translation. Okay. In rigid body dynamics, we have learned in the previous two chapters that we do not only have translation motion, but also we have rotation motion. So the actual kinetic energy formula is not only involve translation, but also we have another formula to calculate kinetic energy, which is also T is equal to 1/2. If for translation, the second component in the formula is mass, then for rotation, you will have Ig, the mass moment of inertia. So we have learned this before. And if in the translation formula, you have the velocity V, then for rotation, we will have the angular velocity, which is omega. And omega is also square. So this is the formula for kinetic energy that represents rotation. Okay, so when we write the general formula to calculate kinetic energy, then it will be T is equal to 1/2 mv square plus 1/2 Ig omega square. This will be the official equation lah to calculate kinetic energy in dynamics, rigid body dynamics, which involve both translation and also rotation component. Okay, so let's take this equation and we look at the equation for the case of three types of motion that we have. So previously we learned that the first type of motion is translation. Translation. Okay. When an object is in translation only, then if the object is in translation only, T is equal to 1 over 2 mv square plus 1 over 2 ig omega square. When the object is only undergoing translation, then there is no omega because the object is not rotating. So therefore, omega will be equal to 0. And then you have the equation for translation. It will be only T is equal to 1 over 2 m v square. Okay, so this is for translation only motion. Okay, why? This is what you have learned in physics before. The actual formula is 1 over 2 mv square plus 1 over 2 ig omega square. But when the object is in translation only, then there is no omega. Omega is equal to 0, which means that the whole thing on this part will also be equal to 0. And therefore, what is left is 1 over 2 mv square only. Okay, so that is the first type of motion that we learn. Second type of motion is rotation about a fixed axis or rotation lah. Okay, so for rotation, from the equations that we have, T is equal to 1 over 2 mv square plus 1 over 2 ig omega square. Now, both sides or both element or component mv square and ig omega square has value. So therefore, for rotation, you can use the equation, you can use the general equation lah. T is equal to 1 over 2 mv square plus 1 over 2 ig omega square. Okay. But also for rotation, let's take for example, we have a rod like this. We have a rod like this, okay, and the rod is, let's say, fixed here. Okay, this is the fixed point O, and then the rod rotates maybe like this with an omega here, and then it goes to vertical position like this. Okay, let's take for example lah. Okay, so what we can do is this is the location of point G, which is in the middle. This is also the location of point G at the second position. So we can use the first equation, which is T equals to 1 over 2 mv square plus 1 over 2 ig omega square. That is one option. You have also another option to calculate the mass moment of inertia about point O. We can also do that. So the equation then becomes T is equal to 1 over 2 IO omega square. Okay, so you have now two options. It's either you use the first equation, which is 1 over 2 mv square plus 1 over 2 ig omega square, or you can also use 1 over 2 io omega square, and this will give you the same answer. So basically what I'm saying is that for rotation, you have two options. So this is or. So it's either the first equation or the second equation. And how do you find IO? IO is basically using the parallel axis theorem lah, which is IG plus MD square. Okay, this is the parallel axis theorem. We have learned this before. Okay, parallel axis theorem. Right, so we learn about parallel axis theorem in chapter 2. So you can use that to find the value of IO. And when you find the value of IO, then you can use the second formula, which is simpler than the first formula. The first formula has two parts, two components. You need to have 1 over 2 mv square. You need to know what is the velocity. And the second part is 1 over 2 ig omega square. You need to know what is the angular velocity. But if you use the second formula, which is 1 over 2 IO omega square, which will give you the same value, you need only to find the value of IO, which is mass moment of inertia about point O. So basically, rather than we calculate the mass moment of inertia about point G, which is the center of gravity, we now calculate the mass moment of inertia about the fixed point O lah. So that is the difference. Okay, so that is for rotation, and we also learn the third type of motion, which is general plane motion. General plane motion. Okay. General plane motion involves both translation and also rotation. So basically for general plane motion, the equation that you have is also both lah, which is T is equal to 1 over 2 mv square plus 1 over 2 ig omega square. Okay, so this is the equation that you have to use when it comes to general plane motion. Okay, but also for general plane motion, you have another option as well, like the rotation. You have, or you can also calculate the kinetic energy by finding the location of IC. So you have now T is equal to 1 over 2 IIC times omega square. So similar like rotation, you have two options. It's either you calculate using the standard equation. This is the general equation lah. This is the general equation to calculate the kinetic energy. General equation for KE lah, kinetic energy. Okay, so this is the general equation. So for when it comes to general plane motion, you can either use the general equation 1 over 2 mv square plus 1 over 2 ig omega square, or if you can find the location of IC, then you can calculate the mass moment of inertia about IC, and you can use T is equal to 1 over 2 IIC omega square. Okay, IIC is also similar to IO, which is IIC. You use parallel axis theorem. IIC is equal to IG plus MD square. Okay, so D is the distance between IC and also G lah. Same goes for rotation. D in that case is the distance between O to point G. Okay, so this is basically the formula that you can use to calculate the kinetic energy based on the type of motion of the object that you are currently solving the problem lah. Okay. Any questions so far before we proceed to some of the example calculation of kinetic energy? Any question? Okay, so if there's no question, let's proceed to an example of kinetic energy calculation. So we have an object here. The weight of the object is given as 100 kg. And also we have here the 3 radian per second, which is omega lah. This is basically the value of omega. This is the value of m. And first, what we want to calculate is we want to calculate the kinetic energy of this object. So basically, this object is currently moving. So the first thing, you need to identify what type of motion is this. Anyone can tell me what is the type of motion of this object?
Rotation.
Rotation, good. So this is currently undergoing rotation. So although it is not labeled, basically point O is in the middle. So this is the fixed point. This is where the object is fixed, the disc, let's call it a disc. The disc is fixed at that point, and then it is currently rotating. So what we want to find is what is the kinetic energy of this disc. Okay, so let's go back to the formula. So we have identified that this is rotation. So when you look at the rotation formula, we have two options. It's either to use 1 over 2 mv square plus 1 over 2 ig omega square, or we can use 1 over 2 io omega square. So let's copy this formula and bring it to the other side. Okay, so this is the formula that we have. Okay, so which one you think that we should use? Which one we should use? Can we use the first one or can we use the second one? Of course, we can use both lah, basically. But okay, let's look at the first one. 1 over 2 mv square plus 1 over 2 ig omega square. Okay, let's focus on this v. What is the velocity of this? What does it mean by velocity? Velocity means that it is moving in a linear motion. So, do you think that this object has linear velocity?
No,
Why?
because it is rotating, only angular velocity.
Okay, good. The object, this is a disc lah. This is a disc. So let's I will write here. This is a disc. Okay, the disc is basically rotating at only one place, static lah, static rotating. So they rotate about point O. It is fixed at point O, and there is no linear motion, which means that the disc is not moving to the right, it's not moving to the left. What it is undergoing, the type of motion is only rotating around and around this fixed point O. So basically, if we look at the equation that we have here, V here in this case is equal to 0. So we have only the rotation punya component lah. So because now the center point is called O, so now these two is basically the same. So you can use 1 over 2 ig omega square because the center point is also point G, or you can use 1 over 2 io omega square. In this case, you do not have to use the what do you call parallel axis theorem lah, because point G and point O coincide. Dia is on the same point. Okay. So now we have decided that to calculate the kinetic energy of this, let's use T is equal to 1 over 2 IO omega square. Okay, O being the center point lah. O and G is now on this, in this case only, the same point. Okay, so next step is we look at the formula. So omega is given. We have this as 3 radian per second. So this will be basically 3 square lah. What we need is IO. We do not have IO yet, so we need to calculate that. Okay, so now this is a thin thin circular disc. So let's thin circular disc. Let's copy from this. Let me see if I can do that. Let's take this and copy, and let me try to paste it here. Okay, so this is what we have from, I'm going to put it here. Okay, from the apa tu, the table lah. Okay, from the table. So by looking at this, which one do you think the formula that we should use? We have now IXX IYY, which is 1 over 4 mr square, or 1 ZZ 1 over 2 mr square, or 1 Z prime Z prime 3 over 2 mr square. So which one is the correct one? Look at the rotation of this. It is currently rotating about this. This is the type, this is the direction of rotation. So which one is the correct one?
IXX.
IXX, are you sure? Okay, look at this. I will zoom it here. Okay, x-axis is here and y-axis is here. Rotation about this axis, meaning that it is rotating like this. So if you look at this as a coin lah, for example, so it will be flipping the coin. This is how you rotate about x-axis or y-axis, by flipping the coin, which is not what is happening in this case. What is happening in this case is rotation about this, which is z-axis. Okay, you have to imagine this. There is a line here, and the disc is rotating like this about this line of z. Okay, so in this case, what we need to use is IZZ. Okay, so you have to be very careful to imagine the type of motion and decide which formula that you need to use to calculate the mass moment of inertia. Okay, so now we know that IO is basically is equal to IZZ, which is 1 over 2 mr square. 1 over 2 mr square. So we have here 1 over 2. M is 100, which is given. And R is not given here. It must be missing in the question. Let me see. R here is 2. Okay, so R here is 2. It is missing in the picture. So let's put 2 meter here. Okay. So R is 2. So now what we have here is 2 square. All right. So let's calculate what is IO in this case. So we have 1 over 2, which is 0.5 times 100 times 2 square, which is 4. Okay, so we have 200. 200. The unit is kg meter square. Okay, so now we have the IO, and also we have the omega. So we can then proceed to calculate T, which is 1 over 2 times IO 200 times omega square, which is 3 square. And therefore, we will have the value of 900. Okay, so T is equal to 900. Who knows what is the unit for kinetic energy? In fact, the unit for all energy lah. Energy has only one unit. Every type of energy, all types of energy has the same unit. So what is the unit for energy?
Joule.
Sorry?
Joule.
Joule, yes, correct. So the unit for energy is joule. Okay, so do not forget the unit. Whenever you do the calculation, you have to put in the unit. Okay, so this is the answer for this for the kinetic energy of this disk, which is 900 joule. Okay, any question on solving this one before we move on to the next question? Any question?
No, sir.
Okay, so let's move on to the next one. Okay, this is now a rod. Okay, this is now a rod. So what is the type of motion? I think everybody should know this is a rotation motion lah. So this is basically a rotation motion. So let's write here rotation. Okay, we know that this is rotation. So let's copy the formula again. So we have two formulas to calculate the kinetic energy for rotation. All right, let's paste it here. Oops, sorry. Yeah, I will copy from here lah. Okay. Okay, so we have these two formulas to calculate the kinetic energy for rotation. Okay, let's see what we have, the information that we have here. So we have 100 kg, which is, this is the M. M is 100 kg. We have the omega, which is given also. Omega is here, 2 radian per second. And we also need to locate the location of point G, which is should be in the middle of this rod. Point G is here, and therefore the distance from point G to O. What is the distance from point G to O? This distance
1.5.
1.5. If the whole total length is 3, then the distance from G to O should be half of that, 1.5. Okay, so we have all the informations that we need. Okay, so now, which equation we want to use? Okay, let's start with the first equation. Okay, let's say we want to use T. Let's say we want to use T is equal to 1 over 2 mv square plus 1 over 2 ig omega square. Okay. Do you think we have v in this case? Do you think we have the velocity in this case?
No.
No? We do have velocity. What? Okay, velocity here is basically the velocity of g. So the equation should be written actually vg square. If you look at the textbook, it will write it as vg square. So what we are focusing here is the velocity of the center of gravity. So when this is in apa tu in motion, point G has the velocity. So let's estimate the velocity of point G, which is the rotation here will cause point G to move in a circular path like this around point O, right? That is the circular path of motion of G, and it will have the velocity which is pointing like this in this direction. This is the velocity of point G. So this is basically Vg. Okay, so we do have the velocity of point G, but it is not given. The value is not given in the question. So can we find the value? Can we find the velocity of G? Can we find or not?
Can.
What is the equation? This is rotation. Remember in the first chapter, chapter 1, we learn the basic equation when it comes to rotation, which is V, in this case Vg, is equal to omega times R. V is omega times R. So do we have the value of omega here? Yes, we do. The omega is 2. Do we have the value of R? Yes, we do, which is 1.5. The value of R. R is 1.5 meters. So we have Vg, which is equal to 3 meter per second. So this is our Vg. This is the velocity of the center of gravity G. Okay, because the point G is moving downwards. following the circular path. So the velocity direction will keep on changing based on the path because the velocity is always tangent to the path. Okay, so that is Vg. So we have now Vg. So if we can substitute in this, we will have M, which is 100. So let's write M is 100 here. Okay. Vg we have calculated, which is 3. So this will be 3 square. So the first component of this equation is done. Omega, we have the value of omega here, which is 2 square. The one that we don't have is now Ig. Okay, so now we need to find what is Ig. Okay, if we look at the apa tu slender rod, let me copy it. Slender rod. Okay. And paste it here. Okay. So we have a slender rod here. All right. So if we look at the slender rod, which one should we use for Ig? For Ig, look at the rotation of the rod. The rod is rotating like that. So point G is here. We are not calculating IO. If we are calculating IO, then we can take the position at the back. But now we are calculating at point G. So basically what we want is, if I can zoom here, what we want is basically this one, IXXIYY, which is 1 over 12 ml square. Why? Why we do not take IX prime X prime? Because this is not point G. We are now calculating Ig. Ig is in the middle here. At the back is not Ig, but it is IO. Later, I will show you the calculation using point O. Okay, so in this case, Ig will be equal to 1 over 12 ml square. So which is we have 1 over 12. The m is 100. L now is the whole length of the rod, not the half length. So we have here 3 square. So then Ig will be equal to, let's calculate. We have 1 over 12. 1 over 12 times 100 times 3 square. So we have 75. So Ig is 75 kilogram meter square. Okay, so now we have here the value of Ig, which is 75. Now we can substitute all the value in here. And let's see what is the answer that we get. So T is equal to 1 over 2 times 100, which is the mass. Vg is 3 square plus 1 over 2 times 75 times 2 square. Okay, and therefore we will have the value of T, which is equal to, let's calculate it, 1 over 2 times 100 times 3 square plus 1 over 2 times 75 times 2 square. So you have 600 joule. The kinetic energy is 600 joule. Okay. So this is the answer that we get by using the first equation. Okay, now let's calculate using the second equation, which is 1 over 2 IO omega square. I just want to show that you will get the same answer. Okay, so to do that, I will resize this so that we have enough space. Okay, oh no. Okay, tak boleh. Because, can I move this a little bit? Okay, saya kecilkan ni sikit. Oh, tak boleh. Dia dah termasuk sekali. Okay, never mind. Let's use another color. Okay, so now let's try to calculate T is equal to 1 over 2 IO omega square. So what we don't have here is IO. So basically, we need to find the value of IO first. So you have two options lah. It's either you use here from the slender rod punya formula here. IO is basically this 1 over 3 ml square, because point O is here. This is basically point O. So you can use this as IO, or you can use the parallel axis theorem. Either one works lah. Okay, so let's use the parallel axis theorem lah. It will give you the same value. So IO using parallel axis theorem is equal to IG plus MD square. Okay, so IG we have 75, mass is 100, and D is the distance between O to G. So when you refer to the picture, distance from O to G is basically 1.5. So we go back here, times 1.5 square. Okay, so which will give you 75 plus 100 times 1.5 square. So which will give you 300. Okay, so IO is 300 kg meter square. Okay, and then we can then substitute the value in here lah. So this will be 1 over 2 IO is 300 and omega square is 2 square. Omega is the one given in the question lah. So what we have here is 300, 1 over 2, 0.5 times 300 times 2 square, which will also give you T of 600 joule. Okay, so it is proven that you will get the same answer by using either one of this equation lah. So you can decide which one that you want to use. The first formula involves a bit longer equation sebab you kena calculate the VG, you kena calculate IG, and then integrate everything in the formula. Whereas untuk the second formula, you need to find IO, which you have to calculate IG first and then use parallel axis theorem. Then you get the value, key in the IO, and you will get the same answer. So a little bit shorter calculation, but will generate the same value. Okay, any questions so far? Okay, there's no question. Let's move on to the next one. Okay, calculate kinetic energy. I think this is the same like the previous one, but this one, the difference is that the first one, the fixed point is here at the center of gravity, whereas now the fixed point is here. So this is the difference. The previous one does not have linear motion, but this one has linear motion, because when you refer to point G, which is here, let's label it as point G here. When you refer to point G travels from here because of the rotation. It will go here. It will go here, and then it will go up here around the fixed point. Like it will go here, and then it will come back here. So it will make a circle. So point G basically is traveling. So point G is traveling from here, going to here, going to here. This is, if you can imagine lah, this is the path of point G. So different from the first example tadi. The first example tadi, if we go back to the first example, throughout the motion, point G here does not even move. It will only stay there. Throughout the motion, it will only stay here. So that's why we do not have MV. We do not have the value of velocity lah. V is equal to 0. Whereas in this case, point G is actually moving. Okay, so macam saya tunjuk tadi, is moving here, going to here, and come back and keep on moving and so on. So the motion is in a circle. Okay. So let's try to calculate this. We have a few value. The mass is given. The omega is given. We have here the value of R, 2 meter. So basically, we have almost all the values. And then let's now copy the formula. Let's copy the formula. And I would like to show that we will solve this using the second formula only lah, which is 1/2 IO omega square. But if you want to use the first one, it should be no problem. Okay, so to use the second formula, T is equal to 1/2 IO omega square. We need to find IO. Okay, so we know that IO is equal to IG plus MD square. Okay, so let's also copy the thin circular disc here, because this is the shape that we have. Okay, this is thin circular disc. I will resize it a bit. Okay, like that. Okay, so thin circular disc. We have basically two options lah. It's either we use the parallel axis theorem, or you can also use this, because this is basically sorry, it's not Z prime. Sorry, it's not Z prime. We need to use XX. We need to use IXX or IYY. That is no. Sorry. We can use the Z prime. The rotation is like this, right? Correct. So it's either we use the IZZ and then use the parallel axis theorem, or you can straight away take IZ prime Z prime. Okay, let's see that we will get the same answer by using any one of this. Okay, so if you decide to use the parallel axis theorem, then we need to find IG first. So IG, because IO is equal to IG plus MD square. So IG in this case is IZZ. Okay, you look at this rotation. Point G is here. Okay, point G is here, and the disk is rotating about this axis. So it will be IZZ lah. So for IG, it will be 1/2 mr square. Okay, so 1/2 mr square, which is 1/2 times 100 times R is 2 meter. Okay, so 2 square. This will give you what is the value? 1/2 times 100 times 2 square, which will give you 200 joule. 200 kg meter square. Kg meter square. Let's bring this little bit here. Okay, kg meter square. Okay. That is IG. Okay, so then IO will be equal to 200, which is IG, plus the mass is 100, and D is the distance between O to G. So point O is here. This is basically point O, the center of rotation. So the distance between O to G is basically this lah. This is the distance from O to G. This is D lah. D, the distance from O to G, which is basically the same value as R, the radius. Okay, so we will key in here also 2 square lah. Okay, so IO will be 200 plus 100 times 2 square. So you got 600 kg meter square. 600 kg meter square. Okay, so this is the value of IO that you will get by using the parallel axis theorem. Now I want to show if we use the I Z prime, which is 3/2 mr square. because if you look at the figure that we have here, the fixed point is basically here. Here is the fixed point lah. If you can imagine it like this, here is the fixed point. This is basically point O. Point G is in the middle. So this thing is basically rotating like this, about point O. This is the direction of rotation. Okay, this is what is happening to this. So we can also use z prime to get the value of IO. So IO, or I will write it or here, or IO is also equal to, from this from this here, okay, IO is also equal to 3 over 2 mr square. So 3 over 2 mr square, which is 3 over 2 times 100. R square is 2 square, which, let's calculate, 3 over 2 times 100 times 2 square, which will also give you 600. Okay, 600 kg meter square lah. So basically we are getting the same value by using either the parallel axis theorem, or you take straight away from the given formula lah. Okay, so now once we have that, kita nak guna this T is equal to 1 over 2 IO omega square. So I will bring this to here to solve this problem, to solve the kinetic energy. So T is equal to 1 over 2 IO omega square. The value of IO we already have. So this will be equal to 1 over 2 times 600. Then omega is given as 4. So you write 4 square. Do not forget the square. Some of the students in the previous semester, they forget to put the square there. So which will then generate the wrong answer for the kinetic energy lah. Okay, so then T will be equal to 1 over 2 times 600 times 4 square, which will give you 4,800 joule. So this is the value of kinetic energy of this problem lah. Okay. Any question so far before I move on to probably the last example for today? Any question?
No, sir.
All right. So if there's no question, let's move on to, I will skip this one because this is the same as the rod that we have before. Cuma dia punya placement of point O is different, slightly different, but the same way to calculate. Let's move on to this one. This is not a rotation problem. So if you look at this object, the wheel here is rolling on the ground and also moving to the right. Okay, so this is basically fall under the general plane motion. So this is GPM lah. This is GPM motion. Okay, so let's go to GPM equation that we learned before. You have two options. So we will try to solve this using both option lah, to see that you will get the same answer. Okay, so we have two options here, two values. And it says a very important information here is that it says no slipping. Okay, so what we have here is, the first one is the value of M. We have M is 100. We have the value of omega, which is 2 radian per second. And we have the value of R, which is 2 meter. Okay, and when it says no slipping, this is like what we learned in chapter 2. It means that the contact point here is the location of IC. So basically this is this is IC lah. This is IC. Okay, IC location. Okay, so let's look at if we use the first equation. So I'm gonna bring the first equation here. Wait, I think I can copy this. Oh, sorry, dia tercopy sekali. Okay, never mind. Let's use the first equation, which is T is equal to 1 over 2 mv square. V is basically Vg lah kat sini. Vg square plus 1 over 2 Ig omega square. All right. Okay, so the problem now is that we do not have the value of G. If as the value of Vg. So if we visualize here, point G is basically here. This is point G, the center. And Vg is basically in this direction because point G is moving to the right. So this is the direction of Vg. Okay. So the problem to use the first equation is we do not have the value of Vg, but we can find the value of Vg by knowing that the contact point is IC. Okay, so we did this before. I have shown this in the previous class, in the previous chapter, where point G, because we know the bottom is the location of IC, point G is basically, it's like rotating about this point lah. Now IC ni macam jadi a center of rotation. Dia macam jadi fixed point. So I can represent IC ni like a fixed point like this. This is what IC is about. It is an imaginary point. It is a point that does not exist, tapi through some conditions yang kita dah belajar sebelum ni, we are able to find or locate the location of IC, and we can assume that IC is like a fixed point. So point G is macam seolah-olah dia rotate about point IC. So when we know about this, then we can use the formula V equals to omega R. V equals to omega times R to find the value of Vg. Okay, we can use this because now we can treat this as if dia adalah rotation punya problem. Because we know the location of IC. So that is why I said the no slipping tu is very important information because it will help us to get the value of Vg. Okay, so now we have omega is given 2. So we can then find V, which is Vg lah in this case. This is basically Vg. Vg. Okay, so omega is 2 radian per second and R is 2 meter. R is 2 meters. So therefore we will have Vg is equal to 4 meter per second. Okay, so now we have the value of Vg. So if we substitute all the values that we have, M is 100. Okay, Vg is 4 square. Okay, next, omega is, we know this is 2 square. What we do not have now is Ig. Okay, is Ig. But we can also find Ig because this is also a disk. This is also a disk. I can, let's go back to this one. Maybe we can copy this and bring it here. Okay, this is a disk. Okay, so if we refer to this, this one, point G is here. Okay, so this is also a rotation about Z lah. This is a rotation about Z. So we can then use this formula 1 over 2 mr square to find the value of Ig. Okay, so let's do that. Ig is equal to 1 over 2 mr square, okay, which is equal to 1 over 2 times 100 times R is 2. Okay, so 2 square, which will give you 50 times 4, which is 200 lah in this case, 200 kg meter square. Okay, so we now have all the values. So now here we know this is 200. Then we can substitute to solve the kinetic energy. So T is equal to 1 over 2 times 100 times 4 square plus 1 over 2 times 200 times 2 square. So we will get the value of kinetic energy that is equal to 1 over 2 times 100 times 4 square plus 1 over 2 times 200 times 2 square. So we will get 1,200 joule. 1,200 joule. So this is the value of kinetic energy of this problem. Okay, that is solving using the first equation. So let's, before we end the class, I would like to show you if we use the second equation, which is now T is equal to 1 over 2 times IIC times omega square. Okay, so now what we need to find is IIC. Okay, so let's try to calculate IIC. IIC, okay, remember we can use the parallel axis theorem, which is equal to IG plus MD square. Okay, so IG we have calculated up here, which is 200. Mass is 100. And D is now the distance from IC to G. Okay, so now, because we know this is point IC, so the distance from IC to G is basically the same as the radius R. So here we have 2 square. So now the value of IIC will be equal to 200 times 100 times 2 square, which will give you, 200 plus 100 times 2 square, which will give you 600. So IIC is 600 kg meter square. And then finally, we can solve this. Therefore, T is equal to 1 over 2 times 600. And then times omega, which is 2 square. And therefore, we will get the value of T is equal to 1 over 2 times 600 times 2 square. 1,200 joule, the same answer like what we had before. Okay. So I've shown that using either one of the equations, you will still get the same answer. The first equation that has both components, translation and also rotation, will results in a bit longer equation because you need to find the value of V, which is not given, but it is very easy to find. V is always equal to omega times R because we can treat this as a rotation problem. But if you ask me, I truly recommend that you use the second equation lah, this one, because it is much shorter. You only need to find IG first, and then from IG you can find the IIC using the parallel axis theorem, and finally get the value of kinetic energy. Okay, so any question so far? No question? All right, so if there's no question, I think that will be all for today. So we have covered the kinetic energy. I have shown that we have 3 types of motion like what we discussed before since the beginning of the class. And for translation is the easiest one lah. Translation, I did not even show the example for translation, because it is very straightforward, 1 over 2 mv square. But the one that you should pay attention to is the rotation, or also or the general plane motion, because we have two components. One is translation and also rotation. We can either use that, or we can use a simplified version or simplified formula by calculating IO, or for general plane motion, calculate IIC. Okay, so in the next class on Wednesday, we will also be doing class online like this. We will go into the next subtopic, which is the work done. Okay, so I think you also have heard of work done before. So we will discuss about work done. And then next week, we will have class as usual, face to face, and we will see how we can combine the kinetic energy and also the work done that we will discuss on Wednesday into the principle of work and energy to solve some problems in this topic lah. Okay, so if there is no question, that will be all for today. Thank you for joining the class. I have recorded this session, and I will also share the notes and also the recording so that you can watch at home. Okay, so thank you very much. I will see you again online on Wednesday. Assalamualaikum and have a good day.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, doctor.
Welcome.